So hi everybody, thank you so much for either attending live or watching this recording later. My name's Ben Setel, and I'm going to speak a little bit about its approach to unsupervised learning today, as well as give a product demo about some of our supervised learning techniques and show how you might use some of our unsupervised learning tools. So let me go ahead and share my screen so I can share my slides. There we go. So you all should be able to see my slides now. So as I said, I'm going to talk a little bit about unsupervised learning, and in particular, I'm going to go through first just sort of what unsupervised learning is in general, then a little bit about using a technique called RAG to apply unsupervised learning to LLMs, and then talk a little about how you might actually use that in practice. So what do we mean when we say unsupervised learning? In machine learning generally, we can sort of think of two types of tasks. There's supervised learning where we want a model to create predictions, and in order to do that, we give it labeled examples. So we say, here's a bunch of data, and here's the prediction you should generate for each piece of data. In unsupervised learning, we don't have that second part. We don't have the answers. We don't have those labels. We can't tell the model what we want it to actually generate. So you might think that actually is a really significant barrier, and certainly it limits what we can do, but we can still find very interesting patterns within data. And one of the techniques in particular that's very popular is this type of clustering and other approaches to just sort of recognizing these interesting relationships between different pieces of data, even without explicit labels. So this graphic is like an example of applying that clustering to actually then do classification, right? So if we got a new piece of data, we could figure out which cluster it fell into and then say, okay, it's a member of cluster 1, 2, or 3, right? And assign it that label, and even without any explicit training data that sort of tells us to do that, right? So that's unsupervised learning in general. But how do we apply that to language? Well, language is sort of interesting because it has these sort of natural patterns to it, right? It's naturally, any sentence is naturally sequenced with these sort of defined parts. So one popular approach is called masked language modeling, where you take any specific part of a sentence, any word, and remove it from the sequence and ask the model to generate it again. So for instance, if you have the sentence, the quick brown fox jumps over the lazy dog, you might mask the word brown and ask the model to generate that word, or fox, and so on. And so we can actually sort of create our own data and our own labels by doing this masking and taking advantage of this sort of particular nature of a sentence or of language. So for large language models, we sort of extend this approach a little bit. And today I'm going to talk about, there's this excellent research paper that uses this approach of using a technique called RAG to help train an LLM to be sort of an information refiner. So first, RAG is short for retrieval augmented generation. And the idea is that LLMs are trained on a very large data set, but if you have some document or set of documents that's not in that training set, LLMs out of the box won't know anything about it. So with RAG, we take text from these new documents that it hasn't been trained on, and we feed it in as part of our question or our prompt when we're interacting with the model to give it information to answer questions about those new documents. So here we sort of do that in three ways. First, we'll give it prompts where we give it all the information it needs to answer a question, and the model has to learn how to sort of find the relevant pieces of information within that broader context. The second and slightly more challenging task for it is we give it some information, but not enough, or even incorrect information. And the model has to infer from its existing knowledge base and the sort of new information it's been given, how best to answer the question. And then in the third case, we give it relevant information, but the information that doesn't directly go to answering the question. So to make all of that a little more concrete, we have this example. If we want to answer the question, what is Anode.ai and where are its headquarters? In the first case, we could say, it's a machine learning company. It's located in New York City, and we could give it much more information. But that sort of core piece there is what we would hope the model would pick out, and is sufficient to answer the question. And in the second case, we could say it's a technology company, but we could also say it's based in Boston, right? And so the model would have to, use its existing knowledge base to refine the answer and figure out if that's sort of reliable or not, right? And in that third case, we say, here are the name of the founders, right? And so we give it information that sort of relates to the company, but we don't actually tell it we don't give it the knowledge it needs to actually answer the question. So I want to talk a little bit about how we actually make these data sets that we feed into the model, because often in these machine learning challenges, creating the input data is really the challenge. And this graphic again is from that paper. So in this example, say we want to answer questions about a Wikipedia page, right? What we do is we take the content of that page, we split it up into a set of sentences, and then we process it differently for each of those three tasks. So if we want the model to predict, a particular sentence within a paragraph, let's say represented by these little pink boxes here, in the first case, we feed it all of the sentences in that paragraph, sort of unmodified, and we check if it outputs the sentence we want, right? In the second case, we randomly replace or mask some of the information throughout the paragraph, including maybe in the target sentence, and we hope we get the correct version of the original sentence back. And in the third case, we just strip out that target sentence and hope we still get it back, right? And we sort of train it to do that. So that's sort of the approach. We use a technique called LoRa in doing this training. I won't go too much into the specifics of LoRa, but the idea is that instead of training all of the weights of a model, which can be in the order of billions, we freeze almost all of those parameters and instead update only a few to do this sort of fine tuning. And we'll go into more detail, I think, later in the day about the specifics of how that works, but it's sort of a high level idea. That's the idea. And then QLoRa is based on LoRa, but uses a technique called quantization, which again, I won't go into too much detail, but the idea there is that instead of using very precise numbers that take up a lot of information, like a 32-bit floating point, you can use smaller sort of numbers that are less precise, but that are therefore less computationally intensive, like a 16-bit floating point, or even an 8-bit or 4-bit integer, things like that. And again, we'll go sort of more into detail, but QLoRa just combines LoRa with that sort of quantization approach. So let me now go to our website and just show a little bit kind of what this might actually look like in practice, and then I'll show you a demo of our supervised learning as well. So first, I'm going to go to our website and just walk through our documentation a little bit about our unsupervised learning and how you might actually do this in practice. So give me 1 second here. Here we go. So this is just from our website, and feel free to peruse this anytime offline as well. But this little video actually is very nice. So the idea is you upload these documents, and then we apply those techniques I just talked about in my slides, and we generate a custom model for you based on those techniques that can then make predictions about future documents, right? And so sort of, again, I won't go too much into the details here, but this is sort of what the code might look like if you wanted to do it through our API instead of through our website. So that's just a very little bit. And now let me go ahead and show you that video that walks through our supervised learning process and has a very similar interface to this workflow on our website. Hi everyone. So today I'm going to show you a little demo of how Anote's labeled supervised training workflow works. So we go to train, and I'm just going to do new demo dataset as our name. I'm going to upload a CSV that has, we'll see the contents in a moment, a column of text and labels that we want the classifier to predict. So here's our input text, and then this is some category, and we're going to use a naive Bayes model to make our inferences. So this is what we're going to actually train. Here's our category, and then we hit train. I have an associated test file that once this is trained, we'll use to actually make predictions. So we go to predict on spreadsheet, and we're going to say new demo outputs. We're going to use our new demo data set, and let me upload. So see, now we have our associated testing CSV. Go to next. And again, we have these sort of input columns and these sort of ground truth columns. So again, it's, some sort of free text and some category of output. We're going to use our naive Bayes classifier, save, and we're going to make predictions with so this is our, tuned naive Bayes classifier. And in just a moment here, it will spit out predictions. And so here we have, this is our actual ground truth category, and this is what the model predicted. So you can see it did a pretty good job. So that's, not completely perfect, though. So that's what our supervised learning workflow looks like. Thank you very much. Yeah, so that's just a little demo of our supervised learning workflow using just a very simple model. And I said tuned in the video. I should have said trained. That's the only correction. But yeah, again, if anyone has any questions, otherwise we can move on.